So if you're a Python developer who's ever built an API with Flask, I bet you've hit this wall. This very, very slow wall. You feel like you've done everything right. You've optimized your database, you've added caching, but something is still just holding your app back. Well, today, we're going to pull back the curtain on a hidden performance killer and show you exactly how to fix it for good. You know exactly the feeling I'm talking about, right? You've spent hours, maybe days, fine-tuning those database queries. You've got a slick caching layer set up with Redis. Everything on paper looks perfect. But then, a user asks for a big chunk of data, say a 20 megabyte JSON payload, and your API just crawls. The user is stuck looking at that dreaded loading spinner, and you're watching your server's response times go through the roof. It is so frustrating. You've probably blamed everything else, the database, the network, maybe even the front-end code. But what if I told you the real culprit has been hiding in plain sight the entire time? What if it's baked into the very way Flask handles data by default, a way that was never really designed for the massive, high-speed workloads of modern APIs? All right, let's dive in and diagnose this thing. The problem comes down to something I call Python's hidden double work. And trust me, once you see what's happening, you'll never be able to unsee it. So the problem really starts with the standard library. See, by default, Flask just uses Python's built-in JSON module to turn your data into something it can send over the internet. And look, that module is reliable, it's safe, but it was never, ever built for speed at scale. It's kind of like using a trusty family sedan to compete in a Formula One race. It'll get there, eventually, but you're gonna lose. So here's what's actually happening under the hood. You've got your Python object, a list, a dictionary, whatever, sitting in memory. Then, JSON.dumps painstakingly converts that entire object into one giant, memory-hungry string. And only after that entire string is built does the server then encode it into bytes to finally send it in the response. Just think about that for a second. We are creating a massive, temporary string in memory for literally no reason. Its only purpose is to be immediately converted into bytes and then thrown away. That is a colossal waste of CPU time in memory, especially when you're dealing with big data sets. We're doing double the work on every single request, and it is absolutely killing our performance. Okay, so how do we get out of this mess? Well, the solution is to bring in a secret weapon that completely changes how we handle JSON. Everybody, meet orjson. It's a super fast JSON library for Python. But here's the magic trick. Its core is written in Rust, and that's the key. By using Rust's incredible speed and memory safety, orjson can handle JSON way, way faster. We're talking 5 to 10 times faster than Python's built-in module. The whole strategy here is so simple, it's brilliant. Instead of that wasteful two-step process, object to string, then string to bytes, orjson just skips the middleman. It takes your Python object and serializes it directly to UTF-8 bytes. No giant, useless string. No wasted memory. It's a straight shot from your data to network-ready bytes. And honestly, this is the best part. Plugging it into your Flask app is ridiculously easy. You don't have to refactor all your endpoints. You just create this simple custom class that tells Flask, hey, from now on, use orjson.dumps instead of the old way. You set this up one time when your app starts, and boom, every single JSify call you make is instantly turbocharged. And you get way more than just a speed boost. orjson comes packed with these amazing quality-of-life features. It can handle things like NumPy arrays and data classes right out of the box, stuff that would normally throw an error with a standard library. It also gets date times right and is much stricter about the data it reads, which can actually help you catch bugs early on. Okay, the theory is cool and all, but now for the real payoff. Let's look at the actual results, because the difference this one little change makes is just staggering. Talk is cheap though, right? So let's see some cold, hard numbers. How does orjson really stack up against the standard library when you put them head to head? Okay, look closely at the units here because that tells the whole story. The standard library takes 1.73 milliseconds to process this data. orjson does the exact same job in just 224 microseconds. That isn't just a bit faster. That is a completely different league of performance. In this specific test, that's an 8-fold increase in speed. 8 times faster, just by swapping out one library. Think about what that means for your API. You could potentially handle 8 times the traffic on your heaviest endpoints with this one simple fix. And if you're a visual person, check this out. On the left, that huge bar is standard Flask, chugging along at over 1,700 microseconds. And then on the right, that tiny little bar is our turbo Flask with orjson, barely making a blip at 224. It is not even a competition. You are leaving so much performance on the table by sticking with the default. So after all that, what's the one big lesson you should walk away with? What's your very next step for building faster and more efficient APIs in Python? It all boils down to this. Stop creating those temporary strings. Your main goal should be to get bytes onto the network as efficiently as humanly possible. A library like orjson lets you do just that. It cuts out the middleman and sends data directly from your app to your user. It's the way it should have been all along. And that's really it, a simple, incredibly powerful change that can have a massive impact on your Flask API's performance. If this explainer helped you out, do me a favor and hit that like button, share it with another developer you know who's probably struggling with this exact problem, and of course, subscribe to the Lily official channel for more deep dives just like this one. Thanks for watching.